So good morning once again. Today we're going to continue our discussion on ARIMA. Let's have a quick review of what we have discussed so far. All right, what we did last time was to simulate different processes. We simulated an AR1 process. Okay. Wait.
Sir,
Yes.
hindi po ata naka-share screen.
Hindi ba ako naka-share screen? Sorry. So kanina pa ako hindi naka-share screen?
Yes, sir.
Ay, sorry. Pinapakita ko na kanina yung ano. I'm sorry about that. I was showing the okay. Wait. Okay. So the objective is to learn or to know ARIMA and then GARCH. These are what I would say sister models. Sister models in the sense that ARIMA is used when uh, GARCH is used when ARIMA fails. Okay, you usually model the returns of a stock price of a stock, for example, and then because of volatility, uh, ARIMA might not be able to capture that. So what happens is that, for example, you are modeling the time series of the returns of Apple or whatever stock, and then it includes the date, the time frame 2008, 2009, maybe to 2020, 2021, which includes some events that could have affected the returns of the price. For example, in the case of Apple, in the case of 2008 and 2009, there was what we call the global financial crisis, which really affected the returns of the stock. So when we model this using ARIMA, you will see that the residuals will be heteroscedastic. So what do we do with that? If the ARIMA model cannot capture that, no matter what log of AR or MA or differencing you do, then the ARIMA model will fail. Okay, so enter the GARCH model. Okay, so I would really request you to please watch already the GARCH model because that's part of your finals. Okay, kasi yung quiz natin yung panel and then yung ARIMA quiz yan. But the GARCH and the VEC will be finals. Okay, so let's have a quick review. Okay, what we did last time was, okay, I'm sorry, I didn't check where we ended. Would you, Kyla, hindi, isa lang yun, pero parang dalawang problems, no? Isang finals lang, pero parang two problems siya. One on GARCH and one on backhand. Okay, so it's not two finals. All right, so could you kindly tell me, Crush, which did we end here? I think we ended here, right? Did we? Yes, one output. Hindi, magkaibang output yan kasi ibang model yung GARCH. Pero you can put it in one RMG file or you can put it separately. So, question ni Kyla. No? Okay, so we said that if you're going to model, for example, it's an AR process. And we know because we simulated the data. And then if you're going to model it as an MA process, you will see that the residuals most probably will be heteroscedastic. So which means that we're not able to capture the model itself. Because when we do ARIMA, we can indicate what order we would like the model to, we would like the time series to be modeled. For example, here, X is an M1 process, right? How do we know? Okay, here. Where is that? Okay, no. M1. M1 is an MA process. We use that ARIMA.sim. The model is MA is equal to 0.6. Okay, so this is your B1 component. This is the coefficient of your log1 of your error term. Okay, and then when we modeled it using ARIMA, where the MA is equal to 1, what happened? So this was a correct model. Okay, so let me just run this quickly. Okay, let me rerun this. So we have this M1, and then if I plot this, we're going to see that this is born out of an MA1 process. So we expect this to be stationary. Okay, stationary means stationary invariance. And if we do the autocorrelation function, okay, so what determines the MA1 process? The MA process is determined by the autocorrelation function. You can see here that it's significant at log 1. Here, the 1 here, okay, and it's significant, it goes beyond this dotted line, okay. But in the PACF, it's slow decay. Alternating siya, no? Parang ganito siya. Let me just, if we get the absolute values of this autocorrelation function, it goes this way. No? Parang ganyan siya. Slow decay siya. Ito, if you put it here on top, then this one, and then this one, it looks like a slow decay. Okay, so if the autocorrelation function has a significant spike at a particular log and a slow decay on the PACF, then that's indicative of an MA1 process, MA process, MA, moving average. So we use the correlogram to determine kung anong process siya, kung AR ba siya o MA ba siya. Okay, kung AR process yan, significant spike at the PACF and then slow decay at the ACF. If it's an ARMA process, no, combination ng AR at saka MA, then it will have significant spike, significant lags at both the ACF and the PACF. Okay, let me repeat that, class. We use the correlogram to determine kung anong process yung time series natin. Okay? Ang determinant kung MA siya is the PACF, autocorrelation function. So this indicates kung MA process siya. No? Kung significant lag yan sa ACF, then it's an MA process. Okay? Pag significant lag siya sa PACF, then most likely it's an AR process. Significant lag siya sa AR, slow decay siya significant lag siya sa PACF, slow decay siya sa ACF, then that's most probably an AR process. Significant spike siya sa ACF, slow decay siya sa PACF, then that's most likely an MA process. Significant lag both at ACF and PACF, then most likely it's an ARMA process. Okay? But today, actually no need to guess kasi pwede namang gamitin natin yung ARIMA. Okay? Okay, so let me just continue this first. So nung minodel natin to, anong lumabas? Okay, we were modeling yung M1 object, yung M1 time series natin as ito, no? 001, ibig sabihin, walang AR component, hindi siya difference. No need to difference this kasi ano naman siya, stationary, no? And then log 1 ng error term. Okay, and we get this result that, okay, ito yung MA1 component niya, 0.5838, which is very close to the 0.6. Di ba yung sinimulate natin to, di ba? 0.6 yung ginamit natin, nag-simulate tayo. Tapos ang lumalabas sa model is 0.5838, so almost 0.6. Okay? All right. And then if we plot, okay, tapos ito yung model natin, ano? Okay. Our time series M1 sub t is equal to epsilon sub t minus 0.5838 times epsilon t minus 1. Okay, so this is an MA1 process. Di ba? Ang MA1, we predict yung ano natin, yung time series natin using the past error terms. In here, lag 1 siya, and then the coefficient is 0.5838. Okay, and if we plot the residuals, okay, it's still white noise siya, no? Walang trend, walang seasonality, so okay yung residuals natin, no? And then, we plot the AC function ng model natin yung residuals. You can see here that, okay, walang mga significant lags yung residuals natin. So, homoscedastic yung error terms natin. Ibig sabihin, okay yung model natin, no? Okay, we expected that kasi sinimulate lang natin yung data natin, tapos minodel natin. Okay? Any questions, class? Paki-chat naman please kung clear tayo so far. Okay, good. Thank you. How about the rest, class? Yeah, good. Right. Okay. Thank you so much for the feedback. All right. So let's continue. Okay, ito yung sinasabi ko last time, no? We know that the time series was an MA1 process kasi sinimulate natin. What if we modeled it? So, no, I'm creating an object called X, and I'm using the ARIMA function. The ARIMA function will generate an output, okay, a model for M1, and we know M1 is an MA1 process. Pero dito, minomodel natin siya as an AR1 process. Look at this, C100, di ba ito yung PDQ natin? This is our PDQ. Yan, PDQ. P stands for the log of the AR process. D is difference. Q is for MA. So, include that mean is equal to false. Wag na maglalagay ng mean. So, let's run this. And you can see that we have a model. Okay, the model is this one. Yung AR1 process niya, 0.411. Okay, but if you notice, the AIC is 2923 as compared to, ano yung model natin dito? Yung MA1 model natin, 2825. So, mas maliit yung MA1 process, no? So, which means this is the better model. In fact, if we do a diagnostic, i-diagnose natin itong model natin, yung time series natin na MA process siya, pero ginawa natin AR. Okay? So, ito kinompare natin AIC. Mas maganda yung MA1 model natin, no? And then, i-draw natin yung correlogram, yung plot ng residuals. You can see here that may significant lag tayo dito. Even in the first, merong konti. Second, meron. Ganon din dito sa PACF. Okay, so this indicates that hindi na-capture, may mga significant spikes pa. May autocorrelation pa siya, no? Na hindi naka-capture ng model natin. So this is an inferior model compared to the MA1 process that there are still significant lags. Okay, so here, let's move on. Dito naman class, mag-simulate tayo ng, let's simulate an ARMA process. ARIMA.sim ulit, ARMA 11. So ang AR component natin 0.4, ang MA component natin 0.7. I think we run this dati na, no? Okay, just quick ano lang. Okay. So you notice here that when we plotted this, parang nga natin to. Okay, so this is the ARMA 11 process. It's still stationary, no? Stationary siya kasi sinimulate natin to ARMA process to eh. No? And then take a look at this. Take a look at your ACF and PACF. Slow decay siya sa pareho. Okay, so sometimes there will be just significant spikes in the ACF and the PACF, which is indicative of an ARMA process, or it can be slow decay. No? It can be slow decay. So dahan-dahan lumiliit yung autocorrelation. This is different from the other one where yung lags, yung mga autocorrelation talagang tumatagal, no? Ito slow decay siya. Over time, the autocorrelation, the correlation among the lags diminishes, no? Ang tawag natin dyan, slow decay. Alright, so let's now i-model natin yung ARMA 11 object natin. We use auto.arima. Ang object natin, ARMA 11. Trace is equal to true. Ibig sabihin yan, i-generate na to. No? Pag hindi tayo naglagay nito, let me just delete this. Magdi-default siya na trace is equal to false. Control Enter. Okay. If I didn't put trace is equal to true, what will happen? Let's see the default. Ibig sabihin niyan, trace is equal to false. Ibig sabihin, hindi niya pinakita, no? Yung step-by-step na na process, no? Okay, so here, ang lumalabas, ARMA 22. Okay, ARMA 22. Yun ang ano niya, yun ang minodel niya, no? But if we use trace is equal to true, capital, i-run natin to. Let's see if we get the same result. Okay, ito, ganun din, no? Nag-aano siya, nag-ARIMA 2202. And then yung AIC niya, 2842. It would be good to compare, no? Tingnan natin kung ARMA 111. Okay, with zero mean, 11, asan na yung 11 dito? 100, 102. Ito, no? 2839. Yung AIC niya. Okay? And R is pointing to us an ARMA 22. Okay. 2839. Pero ito, 2842. No? Okay, ito, 28. Saan na siya? Wait, let me explain, no? Ito muna, initially, ARMA 202. Where's 202? Ito, no? ARMA 202, 2836.592. Ang ARMA 101 with non-zero mean is 2839. Hindi niya pinakita yung ARMA 101 with zero mean. Wala dito, no? Hindi niya sinama sa model yung ARMA 101 with zero mean. Okay, so initially, class, ang lumabas ng best model ito. 2836. This is better than ARIMA 11, 2839. Okay, so what R did is to run this again. Okay, hindi na niya trace is equal to true. Okay, without approximations yan. Kasi ito, trace is equal to true, ina-approximate lang niya kasi maraming models siya tinitinan. So just to facilitate the computation, nag-a-approximate siya. Now, nakita niya ang based on the approximations, ang pinakamaganda si ARIMA 202, minodel niya ulit. Kaya ang lumabas na ngayon na ang ARIMA 202 with zero mean has an AIC of 2842. So this is the best model. Now, how come it's different from the model that we just did, yung ARMA 11? Because simulated lang naman yun, no? Okay? Simulated lang naman yung model yun. It does not guarantee that we will get that the best model to be ARMA 11. Here, it turns out that the best model is ARMA 22. So, two components of AR and two components ng MA. Okay. Take a look at this, no? Si AR1 component at saka si AR2 component. Okay, now take note, kasi hindi pa natin na-discuss, but please do some readings on the relationship between your AR1 and your AR2. Dapat yung sum nila, okay, hindi dapat greater than 1. So 1.2869 plus negative 0.3554, you notice na hindi siya lumalampas ng 1. Ganon din tong si MA1 at si MA2. No? Otherwise kasi kung ano siya, kung lalampas ng 1, magiging explosive yun. Okay, remember, class, nag-ano tayo? Di ba sinubukan natin yan na yung AR1 component, ginawa natin more than 1. Tapos lumalabas siya na ano na hindi pa pwede. No? Alright, how do you generate, okay, ito nga, i-ano na lang natin to control out, naglagay lang ako additional notes dito. So if I want to simulate an ARMA 2-2 process, no? Ito, AR1, AR2, MA1, MA2, no? Okay, so let's run this. Okay, so as guessed, no? Stationary yung data na yan, no? Kasi ARMA process yan. But take note of the coefficients, no? Okay, if I make this 1.4, 1.4, what will happen? AR1 is 1.4, AR2 is 0.1. Tira natin. Okay, error siya, no? Kasi yung mga components dapat, yung sum ng mga components, hindi dapat greater than 1. Alright? So, pwedeng may positive. Okay, kunyari, ito 1.2. Ito, then this is 0.4. Negative. Yan, pwede yan, no? Pwede yan. Kasi, because if you sum that up, okay, pwede siya, no? Ano yung original class? 0. Ano? Para pareho tayo. 0.4 at saka ano? 0.1. Class, pa-unmute nga. Hello, class. Do you have this in your R file? You should have this, di ba? Pakisagot naman please para mabilis tayo class. Tumatagal tayo pag hindi kayo kagad sumusunod, sumasagot. Hello, class. 0.4 ba to at saka ano yung original? Nag-control Z na lang ako. Hirap nyo naman sumagot class eh. Okay, pakisagot naman class ang mabilis kasi nagtatagal tayo eh. Simple lang naman yung tanong ko. Unless you're not there anymore, no? Okay, so ito yung series natin, no? Yung generate natin. Okay, and so if I copy ko na lang to para mabilis. Control C. Okay, if I create a model for X1, hindi ko na ititrace X1, parang final model na. Okay, so we have here, yan, no? Tingnan nyo, no? So, it gives us a ARMA 22 model. Pero medyo iba yung ano, no, yung coefficients. 0.4, 0.1, ito mga 0.14, 0.22. Tapos ito 0.5, 0.2, 0.73, at saka 0.25. So medyo magkaiba, no, but this is the best model. And as I said, there's no guarantee na makukuha natin to kasi simulated lang yung data natin. Okay, so I'll leave that to you, class. Check natin kung ano natin. Let's create this mod 1. Let me call this mod 1. Ay, ba't nandun dun? Ito pala, sorry. Mod 1. Okay, and then let's check, class. Copy ko na lang para mabilis tayo. No. I want to plot the receipt. Bago nitong just to bring home the point, class. Sana yung example natin kanina. Okay, here. Okay. I'm going to create the autocorrelation function. Mod 1. Model natin, mod 1 yung ARIMA model natin, di ba? Yung residuals niya. So let's create the autocorrelation function. Okay, what do you see, guys? No? White noise. Ibig sabihin, okay yung model natin. Alright? Nag-generate tayo ng simulated na ARMA process. ARMA 22 process. Okay, and then minodel natin siya using auto.arima. We call the model mod 1. And then kinuha natin yung autocorrelation ng mod 1, yung residuals niya. And ito yung result, yung correlogram niya. Okay? May konting significant spike dito, but this is negligible naman to. Okay, and then if we try to model, i-model natin yung mod 1, yung residuals niya, class. Let's see what happens. Kung may model pa ba. Okay, look. 0, 0, 0. Ibig sabihin, ano na yan, white noise na yan, no? Yung residual sa model 1 natin. White noise na siya. Unlike yung kanina, yung MA1 object natin, tapos minodel natin as AR, if we use the auto.arima, makikita natin na may model pa yun. Kasi hindi na-capture ng AR1 process eh. Kasi MA1 process yun. Okay, so this one, class, dito nag-create tayo ng isang object, AR, P, apat siya, no? 0.7, 0.2, negative 0.1, negative 0.3. Okay, so gagamitin natin dito. Okay, mag-create tayo ng AR process. Okay, na iba-iba. AR1 na 0.7, AR1 na 0.2, AR1 na negative 0.1, AR1 na negative 0.3. So these are the different A1, no? Lag coefficients ng ano ng AR. Run natin to, no? Para makita natin yung differences nila. So see, dito sabi, for P in 1 to 4, okay, mag-create ang function natin ar.mods P. Okay, so yung P natin, yung 1, 2, 3, 4, which are this one, this one, this one, this one. Magsa-simulate siya ng ARIMA model. Okay, from 1 up to 4, standard deviation is equal to 1. So let's run this. Magge-generate siya ng 4 na AR process. Okay, now that we have 4 AR models, okay, tingnan natin yung plot. So dito, magpa-plot siya ng 4 rows, 3 columns. And then this is the plot. Okay, so tingnan nyo na lang, class, no? This is using the plot.ts. Right, so i-run natin to and then i-ano din yung ACF at saka PACF. So let's run this. Okay. Okay, tingnan natin to, class, no? This is AR1. Lahat to AR1, no? Okay. You notice that the series is stationary siya. Wala naman siyang wala naman siyang trend, wala siyang constant naman yung variance niya. Okay, and then you can see, tinan niyo to, class, yung mga ano, yung mga PACF niya. Mga significant spikes, no? Significant spikes at lag 1. And then yung mga ACF niya, these are slow decays, no? Okay? So it was more to illustrate yung differences ng AR1 process with different coefficients. Ano yung coefficients na ginamit natin? 0.7, 0.2, -1, and -0.3. Alright, ganun din sa MA, class. Okay, we will not run this anymore. I hope you run this. Sige na nga, i-run na nga natin. Para makita lang natin yung difference. And then i-run natin tong plot ng MA. Okay. So all of these are MA1 process. So lahat sila stationary. Ito yung data natin, no? Stationary. And then what do you notice? Okay, si MA, okay, makikita natin yung MA, 0 to, no? 0. So ito yung 1. So significant siya at lag 1. Significant at lag 1, significant at lag 1, significant at lag 1. Okay, and then as far as the PACF is concerned, medyo may pagka-slow decay siya. No? Okay, alternate lang. Slow decay siya. Okay, so this is an MA process. Nakita natin yung difference. Okay, this is 0. 0, talagang 1 yan. Kasi ano yan yung autocorrelation ng series with itself. Kasi lag 0. Ito lag 1. Kita nyo dito yung correlation. No? Okay, we can see here the significant correlation sa ACF, which indicates that this most probably is an MA process, which is correct. MA process talaga. Okay, let me pause for a while. Paki-chat please kung clear tayo so far. Okay, thank you. All right, so I hope by this time clear na sa atin yung AR process, MA process, ARMA process. Okay, so here are some more notes. Okay, I leave that to you guys to read. Na-discussion naman natin to, no? So this just summarizes the equation. AR1 process, Same lang yan sa ARIMA 100. Same lang sa ARMA 10. Ito yung equation niya. Okay, this is just a repeat of what we discussed before. Okay, ang ARIMA 111, ibig sabihin nun, yung time series natin transform. We're not using the original time series already. We are using the difference time series. Ibig sabihin nun, ay ima-minus natin, kunyari ang series natin, 50, 40, 30, ganun. No? So, ang mangyayari yan kapag, if it's, kunyari, 40, 50, 54, 20, 45, etc. Pag sinabing difference time series, okay, let's say this is the earliest, yung latest sa dulo, no? So, i-difference natin siya. Magiging, ano yan? Magiging 50 minus 40, 10. So, 54 minus 50, magiging 4. 45 minus 54, magiging negative 9. Okay? So, this is now the model that this is now that series that we're modeling. Ito na. So, that's the meaning of difference time series. If this is 2, then we'll have another differencing. Magiging 4 minus 10, negative 6. Tapos negative 9 minus 4, magiging negative 13. So ito na yung second differencing, ito na yung gagamitin. Okay, so this is the original series. This is the difference series. And this is the first differencing, second differencing. Okay, madalang naman yung umaabot ng second differencing. Although I've seen some data na umabot pa nga ng third or fourth differencing. But that's really the exception more than the rule. Okay, clear class yung yung difference. Paki-chat please. Kung ano yung pag yung difference time series class, hindi na yung original ang ginagamit ha. What we are using is a transformed series already. Nag-difference na tayo. Ba't natin ginagawa yon? Eh, kapag may trend at saka non-constant yung variance. We difference the series so that it can be transformed into a stationary time series. Why do we need to do that? Because we cannot model the time series if hindi stationary. Okay. Babalikan ko lang sandali class yung AP natin. Andito pa ba si AP? Naalala niyo si AP? Ito, no? Wala na yata ito. No? So, I'll just okay. So, auto.arima, AP, and then trace is equal to true. I-run natin to class. Yung AP na model natin, if you recall, plot ko lang to Okay, plot lang natin to si AP here. Alright. Diba? Ito yung AP airline passengers natin. And it's not stationary. No? It's not stationary. Meron siyang trend. Okay? May trend siya. May seasonality siya. May trend, may seasonality, tsaka non-constant yung variance. So, definitely, class, may kailangan transformation dito. Okay, and what will be the transformation? Well, let's ask Art to solve it, no? Ano yung ARIMA model na dapat dyan? Trace is equal to 2 natin para tinan niya yung mga steps. Alright, so what do we find here? Tinan niyo yung model, no? Alright, see here, the best model is 211. May difference siya. So may log 2 tayo sa AR process, may log 1 sa MA process, and then you can see here may pangalawa, no? 0, 1, 0. Tapos may 12. What's this for? Okay, ito guys yung 0, 1, 0. Ibig sabihin, may differencing tayo sa 12. Okay, why is this so? Remember, seasonal yung data natin. So ang ginawa dito, i-difference din natin yung every 12 months, yung January minus January, February minus February, March minus March, to address yung seasonality niya. Okay? So this is the first time you met this, no? ARIMA 211, and then may S pa siya, no? So actually this is what we call SARIMA, no? This is SARIMA kasi seasonal autoregressive. Let me write that kasi baka makalimutan nyo. Pag may ganito class, tapos sasabihin niya kung anong cycle, kung anong lag yung ima-minus. Okay? Dinifference din kasi. So yung data natin, hindi lang dinifference yung per per consecutive month. Dinifference din yung by month, no? January to January, February to February. So dalawang differencing to. So this is called SARIMA. Okay? SARIMA. No? So that's seasonal autoregressive integrated moving average. So yung integration natin dito, hindi lang dun sa consecutive na months, but also seasonal integration. Nagtanggal din tayo, no? And lahat may integrated at lahat sa 1 and lahat din sa 12. Okay? Alright, so pag nakakita kayo ng ganyan class, bakit dalawa to? Meron ng isa dito, meron pang isa dito. The first one, class, is the regular ARIMA. No? AR1, AR2, MA2, and then difference. Yung second one naman, ito, minomodel din yung lag 1 din ng yung seasonal, no? Okay, ibig sabihin January, February, pati yung MA. So medyo mas complicated na tong model na to, no? But the best model, sabi niya, is laging nagdi-default sa pinaka-simple. So the lesser the more basic the model is, the better. Kasi lower yung kaiki nun. Right? If you can see here, it's AR1, AR2, MA. Tapos kasi walang walang component yung AR dun sa seasonality, no? Kaya walang value. Kung may value to, magkakaroon pa ng ng seasonal na AR1, tsaka seasonal na kung whatever, no? Seasonal na MA. Pero dito sinabi lang, dinifference natin yung month, no? Yung every same month, January to January, minus natin yun para mawala yung seasonality. Okay, pause muna ako, class. So sabi natin, di ba, babalikan natin yung AP na yan, no? And this is the model, class. Hindi lang natin diniscuss ng una kasi medyo complicated na, no? Complicated siya in the sense that nagsi-seasonal differencing din tayo. Okay? And the best model is 211 ito, no? Ito. 211010, this one. 1018 yung akaiki niya. 1018.165. Okay? 1018.165. Tapos rinan na ulit niya. Okay, and then this is the final value. AR1 component, MA1 component, MA1 component. Okay, pause muna ako, class. Please chat if this is clear. Okay, thank you. So first time natin nakamit ng ng SARIMA, no? Seasonal autoregressive integrated moving average. Okay, sa ARIMA yan na yung yan yung pinaka-complicated. Tapos meron pa tayong seasonality component dito. Yung mga ganitong models, no? Ito. But notice, class, na na infinite na yung mga yung may mga AR at saka MA component na seasonality. Yung akaiki niya infinite na. It just goes to show na, pero ito pwede So take a look at this. Yan. Yung 1-1 na seasonal na AR at saka seasonal na MA, infinite, ibig sabihin mataas na masyado yung nila, akaiki. Kaya hindi na rin-reflect dito. But here, meron tayong ARIMA 211-110. So ito, meron kang AR2, AR1, AR2, MA1, meron ka pang seasonal na AR. Okay, may seasonal na AR ka. Alright? Okay, so let's move on. I think clear naman yun. I just wanted to make sure na binalikan natin ang AP para makita natin kung ano yung model niya. Okay. So ito, yung differencing, in-explain ko lang. Pag walang differencing, pareho lang yung series. Pag may differencing, ima-minus natin y sub t minus y sub t minus 1. And then kapag second differencing na, yung difference data, ima-minus pa rin natin. Okay? All right, so let's go here. Okay, ito. Okay, ito guys, ang nangyari dito, may constant dito. Kanina yung ARIMA.sim natin, walang constant. Now, how about if there's a constant? Take a look at this. Let's create this object m is equal to 1, set that seed natin, and then you have here a small constant ar1.small. Simulate natin. ar1 is 0.1. Okay, 0.1 yung natin. And then, dagdagan natin ng intercept. Okay, ng constant dito. And then, i-run natin to. Okay, it will still be, it will still be as a stationary time series. Okay, and then if we model it, hindi na lumabas yung Okay, autocorrelation. You can see here that significant lag at 1 sa PACF. Pero dito, mukhang nadagdagan, nadagdagan ng significant lag din at ACF, which indicates that baka MA process din to, Kasi significant lag at ACF, significant lag at significant spike at lag 1, okay, in both PACF and then ACF. And let's see what model ang niya, sinasuggest niya. Okay, in fact, ang lumabas sa model, the best model is MA1. MA1, hindi AR. Okay? MA1, hindi AR. Kasi, class, kapag masyado na maliit yung yung AR1 component, it will approximate an MA model. Okay, that's what it's saying here. If the AR process that we simulated has a very small coefficient, ito 0.1 lang, okay, then this will approximate an MA process. Okay? Clear yun, class? Tingnan naman natin itong large. So, ganun din, but this time, the AR process is 0.9. All right. If we run this, Tapos, in-AC ko, autocorrelation function. Tingnan natin, autocorrelation function ni AR1 large. And max.log natin 18. I-plot natin to, class. All right, what do you see? Di ba? No doubt that this is an AR1 process. Significant spike at log 1 and then slow decay yung ACF natin. Okay, so no doubt the simulated series that we generated is an AR1 process. In fact, if we, saan na yun? If we run this, yung auto.arima natin, lalabas siya na AR1 process yun. Yan, tinan niyo. No? Ay, wait. Small pala yung nalang ko, sorry. Small yung naran ko. Asa na si large. Ito. Yan. Okay? In fact, ano nga eh. Okay, what happened here? ARIMA 01, difference lang. Difference niya, no? So, ibig sabihin, hindi stationary yung ano natin kanina, no? Ang lumabas dito, the best model is just difference it. A different series, no? So, ang lumalabas yung ARIMA natin, yung large natin kanina, ito, yung 0.9, lumalabas siya na kapag i-difference natin yan, okay, then you will have already white noise. So, hindi na kailangan hindi na siya kailangan i-plot as an AR1, no? Okay, this is interesting. Okay, saan na tayo? Okay, then there's, by the way, there's this function, itong forecast, itong ARIMA, no? Anong difference itong capital A na ARIMA at saka yung kaninang ginagamit natin na small a na ARIMA? What's the difference? Meron kasing small a, di ba? Yung kanina, no? Okay, this is coming from the stats package. And then meron ding big A. Where's that? Okay, baka malito kayo, class. Ito na big A. So this is coming from the forecast package. All right? So let's run this. So we're going back here yung ARIMA small, ano? Run natin to. All right. So what do we have here? You can see here that we use this from the forecast package. Yung ARIMA small natin, okay, it's AR1 process, and then nag-include tayo ng min. Include that constant is equal to 2. Now, why? Kasi, class, di ba, nag-plus m tayo dito, no? Nagdagdag tayo ng constant sa model natin. Yun. Plus 1. So, ang lumalabas dito sa model natin, yung mean niya, yun, 1, no? Di ba? So, you have here the AR component, AR1 component, and then the mean. Ano ba yung AR1 natin dito? Di ba, 0.1? So, it's 0.18. So, medyo malapit naman, ano? Okay? So, Ito, class, we were able to incorporate yung constant. Include that constant is equal to 2. Okay, and it turned out that, ano ba yung akaiki nito? 1449.16. Ano yung akaiki kanina ni MA? Run ko ulit, no? So if you compare the akaiki, kasi ito yung auto.arima natin to, no? Ito. Auto.arima natin. Alright, ang lumalabas, MA, di ba? Ito, MA. Right? MA, tapos, naglagay din siya ng min. Pero ang model niya dito, 001 with non-zero min. Best model is, 001 with non-zero min. So, lumabas talaga yung min. Tapos, MA1 siya. Tapos, dito naman, okay, AR1, and then yung min. So, bakit, ang question dito, bakit, si AR1 small, why is it, using ARIMA, it's an AR1 process with a min, pero using the other one, yung auto.arima, ito, lumalabas na here. MA1 siya with a min. Okay, di ba, class? As yung ARIMA 1 dito. Ito, no? ARIMA 100 with non-zero min, 1450. 1450, yung akaiki niya. Ito, 1448. So, mas mababa yung akaiki ni MA1. So, what can we learn about this? What can we learn about that, class? Does that mean that if the MA1, AR1 is very, very small, it approximates an MA1 model? Kasi dito naman, ginamit natin si forecast package, tapos nag-ARIMA tayo, capital A, ganun din, no? Order natin 100. The akaiki is 1449.16. Mas mababa yung akaiki dun sa MA1. What if we change this? No? Okay, so let me copy this. Okay, then let's change this into 0, 0, 1. Okay, what do you see, class? 001, lumabas na akaiki. Okay. Akaiki niya 1448, pareho ng isa kanina, no? Tapos ang ano niya, ang coefficient 0.19, ang mean 1.007, halos pareho nito. But the difference is that in the akaiki. Now, it's almost time. I want you guys to, ang gagawin nyo, mag-create kayo ng object, no? Whatever object. Tapos i-plot niyo yung i-plot niyo yung autocorrelation function nitong model na to at saka yung autocorrelation function nung isa yung 100. And then try to see kung ano ba yung mas magandang model doon. Okay, we're trying to look at the situation where your AR1 component is very small. Kasi generate natin tong time series na to using a very small AR1 series. No? Ito naman very big. So, anong mangyayari, class? Okay, na-answer na natin to. What happens if the coefficient is greater than 1? Okay, what happens if the coefficient is 1? Okay, this is a random walk. No? Okay, ito nasagutan na natin dati. No? So, ang questions dito, sa AR1 component, what happens if the AR1 component is very small? What happens if it's almost big but not greater than 1? What happens if it's greater than 1? This one we already answered before. Sabi natin hindi pa pwede to, no? What happens if it's 1? Yan, no? So, i-run nyo to, class. Okay. Ano nangyayari? Ay, ba't di AAPL2? Ito, AR11, ARIMA.sim, ano mali ko? Okay. Ano sabi dito, guys? Nag-error siya kasi hindi stationary, di ba? Eh, yung 1 na to. No? So, less than 1 or equal to 1, it will not run. Okay? All right. It's already time. Okay, hindi mo lang tayo umabot ng ano. Kailangan talaga natin class mag Saturday. No? Okay. So, ito, kasi ito yung ano ito yung magiging exam nyo, yung, ang imo-model natin yung returns. Okay, so kindly please go through this. Kung pwede sana, pakirun na, no? Para next Saturday, mabilis lang tayo dito. We have to finish this already and then move on to another topic yung guards. So for your assignment, please run this. Okay, so sana pasok nyo next meeting, pakirun na to. And then, quick discussion na lang tayo, no? Okay, para we're able to cover, we need to finish this. Sana matapos natin to in 30 minutes para makapagsimula tayo ng guards next meeting. All right, so that ends our discussion for today. Let me stop recording.